5.2 billion in 2030, and we see in the UAE about 96.0 billions in 2030, and on the Bahrain, Kuwait, Oman, Qatar, we're seeing almost 46 billions in 2030. This is all a contribution to the GDP, which gives a bright path for the AI to contribute in these countries. So if we compare healthcare, education with other sectors like energy, constructions, we see the absolute contributions is a little bit bigger in these areas comparing to healthcare and education. But when you compare the contribution as a percentage to the GDP, we find out that healthcare and education will get the big percentage of contribution to the GDP because it's going more faster, and the sector is a little bit larger than energy and construction and other industries. Also, if we are talking about, if we see the patterns of machine learning, deep learning, and other AI technologies, if we compare them across the categories, we can see life and medical science ranked the third category, where most of the AI patent is produced. So you can see here we get a couple of subcategories starting from physiological parameter monitoring all the way to drug discovery. Then also education is listed within the list of the AI patents. If we compare the patents based on the categories of AI technologies like machine learning, computer visions, and so on, we will see this is very, very important to be noticed that life and medical science has the majority of the patents regarding to machine learnings, which is 18,000 plus. And also if we compare the computer vision category, we can see life and medical science is ranked in the third category. Education is still growing as a AI patents in these directions, but it will eventually jump in the future as we see more technologies, AI technologies in the education. So let's take some cases, use cases, how AI is going to transform healthcare. So there are challenges that are faced by the healthcare systems nowadays and also in the past, where there are unstoppable forces like population aging, as Mr. Sultan already mentioned in the beginning of this webinar, and also changing patient expectations, a shift in the lifestyle choices as people are tending to use technologies more. Their habits about their health is changing from the old in the past and this future. So this will lead us to that healthcare systems are facing tremendous growing demand for their services now and in the future, raising costs and a workforce that is struggling to meet all these needs. So we can say that AI has the potential to transform healthcare and help addressing some of these challenges. So AI, if we talk in the world economy, it's predicted that it's going to contribute over 15 trillion to the world economy by 2030, which is the greatest impact of AI will be in the healthcare. So why the evolution of AI in healthcare? It's on the peak now because two main reasons. First, we have a high availability of the medical data, and also the development of complex algorithms. In the past, use machine learning, which can solve a low dimensional data, but now with this big data, we have a high dimensionality. So deep learning helps a lot in this direction. So one first use case is a medical diagnosis. So researchers at Stanford, for example, University, they developed a model to detect the pneumonia disease and other diseases. So they are giving the task of these X-rays to the radiologist and also to the model. So they are comparing the result, where they eventually found the accuracy is sometimes the same and sometimes is better than humans. Another way to see this is also for the MRI. MRI analysis programs takes a long time to analyze the MRI recording to get the results. So MIT developed a model, it's called Fox-Morphy. It's a CNN model that took seconds to perform the MRI analysis, which took hours from the MRI analysis programs to produce the results. Also in the area of early detection disease, which they always say precaution is always better than the cure itself. So the companies are producing wearable health trackers like Fitbit, Apple, Garmin, and others to monitor health factors on the human being to predict heart attacks and other diseases from happening. So, for example, Apple used AI to build a watch that monitors individual health, predict the occurrence, which can monitor, also collect the data about heart rate, sleep cycle, breathing rate, and all most of the things that can be tracked. So give more indications about what's going on and what they are expecting to happen, so it can be prevented and help lives. Also, another area of early detection is the use for the embedding dementia, like Alzheimer's disease. They use the sensors to be worn around the body, so it can track some of the factors of the behavior walking, so they can predict any kind of these diseases in a cheap manner, instead of using MRI and other imaging techniques. Also, Google has announced this a couple of years ago, is diagnosing diabetes. Retinopathy is they are seeing a lot of things through the image of retina of the human beings. Through the eyes, they can see a lot of factors. They can predict the age, biological sex, smoking, non-smoking, BMI, and from there they can also predict the model that predicting the cardiovascular diseases from the data of 5 years. People experiencing these diseases and people are in good health. So they build the model that predict these cases. Also, we see in the healthcare, in terms of personalization of healthcare, the virtual nurses, where from the visit to the other visit to the doctor, you are being helped with the virtual nurses. They tell you what to do, and they are connected, these nurses, to the medical devices with the patient at home, so they can give more alerts, use speech recognition to answer questions, use NLP to analyze the data that's reading from the devices. Also, errors is a major errors in the industry of healthcare. It's a factor of death and life. So 1.5 million energies resulted from accidental medication errors, and AI could help in this area by predicting. Let's give an example: a doctor giving a dose by mistake, increasing the dose, so that AI can predict from the history of patients similar to this patient's symptoms to indicate this dose is wrong. Also, the last use case for the healthcare is patient flow optimization. From the point of view for the manager of the hospitals, they need to know the journey of the patient. So they want to manage the length of stay for the patient from the door to the door. So there are a lot of companies putting a lot of money on this so they can track and help the managers of the hospitals to increase the flow and optimize the flow of the patients, and they know where are the bottlenecks of the system so they can optimize the staffs. They know where to move the staff from station to another stations, and this can be done in ER, it can be done on the whole hospital. So we're going to move now to the use cases of education. So the current education is based on a lot of challenges, like routing knowledge transfer, centralized curriculums, limited teacher resources. There is a burden of administrative tasks done by the professors and teachers. The system that we are seeing now is not scalable in the future. Lack of flexibilities and accessibility. Also, the learning cost is increasing as we go on in the future. So AI will help on this a lot. So I want to just point out one thing that we see in the future. As a scientist, AI scientist, we see the future is going to be a non-routine creative knowledge work. The process of transferring the learning, and at the end of the semester or end of the year, they're going to evaluate the acquisition of this knowledge. This will end in the future. So we are working toward the designing of solutions to solve problems. There will be no routine knowledge work. So nobody in the future will hire you because the knowledge that you know, because the knowledge is there. Everywhere you go, Google, YouTube, you can find the knowledge. The companies in the future will hire people because what they are able to do with their knowledge. So the system of education will change gradually in the future to meet what we can say that solve real problems, and also experiencing solving these problems in a simulation life. In a simulation life, this will move the education from a basic knowledge transfer to the next level, which is going to be solving real problems with experiencing solving the problems with a simulation of real lives. There are tremendous use cases for AI in educations. We have seen a lot of them nowadays, and there are plenty to come in the future. For example, chatbots are there. There are maybe Georgia Tech are using a beautiful and powerful chatbot to sharpen skills and improve the weak spots on the students outside the classrooms. Quick response, they can answer questions very quickly. So the time of the teachers and professors can be used to focusing on the learning itself, not answering repeated questions asked in the future, in the past. Also, one of the important things is personalized learning. So if a student sitting in the class, that does not mean the student has the same knowledge as his colleagues. No, the student has some level of skills, which is going to be different from the other students. So personalized learning, they will use a knowledge graph where a historical skills of the student will be measured. So, and a learning path will be built for this particular students, so the teachers or professors can track those students individually to measure and evaluate and reevaluate their progress in a personalized fashion. Also, automating the manual process. Automating the manual processes would be a big shift to increase the time for learning, solving the problems, building simulations environments for the professors and teachers in the universities and schools. Also, the last thing that I want to mention is making learning accessible for all students anytime, anywhere. This is going to be the next revolutions in educations. We have seen this Coursera and other similar education, online education platforms. So in the future, we might see universities, the whole university from the start until the end will be online. There is no existence for the university on the earth. It's a virtual university. So thank you so much for listening to this, to my talk. I hope I covered most of the things for education and healthcare, and I will be pleased to answer questions at the end of this webinar. Thank you, Brother Sultan.
Thank you very much, Dr. Majdal. It's very thoughtful and insightful and expertise, knowledge about health and education, and there's a lot of things to think about or to talk about, inshallah. But meanwhile, we go to Dr. Nizar Zaki from Al Ain, United Arab Emirates University, to talk about machine learning, inshallah. Dr. Nizar, the floor is yours, please.
Thank you very much, Sultan. First of all, I would like to welcome our colleagues from KSU. It's a pleasure to talk to you and to exchange research ideas with you. So my name is Nizar Zaki. I'm a professor of computer science and also a director of the Big Data Analytics Center here at UAE University. I'll be talking about machine learning applications, and I'm glad that at least Dr. Safran spoke about many applications that we're going to cover. Here, I'll be focusing more on what's machine learning and what kind of projects we are actually doing under the Big Data Analytics Center at the moment. So before we talk about machine learning, if we circle back to artificial intelligence, we can straight away know that artificial intelligence leverages computers and machines, and the purpose is to mimic the decision-making capabilities the human mind has. So to do this, of course, we need machine learning. So machine learning, that's why become a branch of artificial intelligence. And here, in this case, the focus will be on using data and algorithm to imitate the way human learns, because in order to mimic decision making, you need to, before that, we need to have a learning capabilities that machine learning actually fulfill in this case. And that's why, in my opinion, machine learning is the most important, is the heart and soul of artificial intelligence. Then, of course, recently deep learning came in the picture, and it's again, it's a branch of machine learning. The only difference in here is in deep learning, we're trying to automate some of the process of the machine learning framework, especially the way the features and attributes are extracted. So, for example, when you use deep learning and you input simple images, so you need to use here something like convolutional neural network. So the convolution step is all about extracting these features automatically and then pass it to, let's say, a neural network to for classification purposes or predictions. Many people keep on asking me question, what's the difference between big data and business intelligence and data science and machine learning? And actually, I found this infographic very insightful in that sense. If you look at the bar where you can see past and future, this is very important. So we can look at these definitions when we look at when, why, and what in this case. So when we start with when, speaking about big data, for example, or traditional data analytics work, we can say this is the first process of the whole pipeline when we begin by collecting the data, integrate it, and in this case, of course, big data help a lot in getting all kind of diverse data, all the V's together in order to get the data prepared. Then business intelligence is always built on organized data. So once the data is organized, we have something like data warehouses, then we can straight away use business intelligence. And that's all about descriptive statistics. We look back and we can make decisions based on this. But when we look at machine learning, we find it is all about predictive analytics. We want to see what's happening in the future. And that's why when we look to what in this diagram, for example, we realize straight away that machine learning has three main branches, which is supervised learning. In this case, we have a target for our data. And since we have a target, we can know why are we reaching this decision. And this will give us, the opportunity even to find patterns within the data. For example, let's say a bank giving a loan to person X. So when we look at in this person X, then we can see it might be probably 90% of the people applied, for example, have a salary more than 30,000 Riyal or dirham, for example. Then it became a pattern that could be used for future decision making. So, but sometimes we don't have targets, and this is where unsupervised learning will be helpful in this case. And since we don't have a target, the best way to go is to group objects or samples of the data together by finding appropriate proximity in this case. And it could be a distance, whether it's Euclidean distance or Manhattan distance or Chebyshev or any kind of measurement. And then we have reinforcement learning. Reinforcement learning is kind of similar to supervised learning. The only difference in here, we're not trying to minimize the loss, but in actually we're trying to maximize reward. Let's say we want to move an agent from A to B. We have obstacle on the ways, they are right directions. Then we can do that by giving a reward if the agent go to the right direction, otherwise penalties if it's not. So we can see the difference here, and we can straight away, if we try to figure out applications around these three areas, which is supervised, for example, you always see applications related to classification and regression. So if classification that comes to things like image classification, fraud detections, and all that kind of, and it could be you would like to predict, let's say, a value. So you're to forecast, for example, temperature, or you want to find how much the students will get at the end, the total grades, or for example, or stock market value. Then in this case, of course, this is typical supervised learning work. We can also look at unsupervised learning. In this case, of course, clustering is the key here. If you would like to, for example, look at customers and you want to figure out their buying behavior, or you want to target them for certain marketing campaign, so you want to find similarities between those customers, then this is sit perfectly in here. Dimensionality reduction is another area which could at least help in reducing the number of features, and then we can have even better visualization and better analysis and fast analysis as well, because we're reducing the complexity. There is another way, also, whenever you think of reinforcement learning, the way we describe it, then straight away comes to your mind something like robot navigation and games in AI, whenever there is a movement from position to position. So I'm not going to spend time here because of the time limit on how the machine learning framework looks like, but this is the typical machine learning framework. Start from unsupervised or supervised learning. Regardless, we have data, then we extract features, then we have a machine learning system, and depends on, as I mentioned, whether we have target or not. That could lead to grouping or developing of predictive models that could help us to classify data. Then, of course, this system is evaluated by having another testing data set that validate the system and make sure it's okay, so we can use it for future predictions. So here at the Big Data Analytics Center, as I mentioned, I'm going to talk briefly about some of the projects going on. And the purpose for this is to invite our colleagues also from KSU, if you would like. If some of you see this project or that project interesting, we can have another meeting and we can talk in details about it. So under the Big Data Analytics Center, we have 6 sub-themes ranging from medical imaging to computational sciences to health data science, data privacy and security, natural language processing, and AI and machine learning. I'll give you a kind of flavor of what kind of projects we do, but I try to make it diverse in a way that whoever have different interests can fit in. So this is a project that we're working on. Everyone is talking about sustainable development nowadays. And if you think of it, here we try to approach the sustainability in different way. So one of the sustainable development goals by the United Nations, for example, is detecting poverty. And to do that, using things like satellite images has become very interesting. So in here, we tried in this project to look into using different perspective by looking at cars on roads. Let's say we tried to do this study in Dubai, and we're extending it to the whole country. If you just use deep learning in this case by extracting some satellite images, try to train the convolution neural network on what kind of cars you could picture and identify on the road. We manually annotated this, and then we applied for all kind of tiles and images for the whole city of Dubai. Then you can see on your right hand side the number of cars reflecting how tall the bar is. But if you see it, it can tell you exactly where the active places in Dubai. If you are familiar with Dubai, this is straight away, you know, this is looks like the right call here, because you see areas close to Old Dubai or areas close to the Gulf or facing the beach. You can see the concentrated on people and the happening areas. So this is will help in planning a lot of activities, in knowing the well-being, in knowing where the low developed places, and of course that's quite interesting. We're still working on this to improve the accuracy. We're trying to also incorporate more activities and more you can say indicators or of economical level on each and every area in Dubai. So another project here, I think Dr. Safran also mentioned educational projects. Here in this project, we are trying to detect student at risk. The only difference here is we're of course using machine learning and deep learning. The only thing is we're focusing on making explainable system here, because first of all, many machine learning techniques are used in the past, but it can detect student at risk or not, but we don't know why. And here the focus is what kind of remedial action we take. First of all, we started by taking something like rule-based, and you can see from the heat map in your top right corner there, you can see these are the rows in this case are students, the columns are different evaluation measures, and you can see whenever it's red, that means the student started to have some downfall in the performance, and some student pick up again, and some student continue in this. This is one, and then we feed it some of this information, plus a lot of other information we find it useful, including the prerequisites of the courses, the personal information of the students, and we were able to even enhance the model in a way that we can accurately detect student at risk early on and automatically produce what kind of corrective measures the instructor should take, because we circled back to the features led to this solution, and then we started to see why the students are ended in this category and that. So another project here, also that Dr. Safran mentioned it briefly, we work on dementia as well. We have actually a team working on studying, for example, the structure-function relationships using deep learning. So by structure, we extract features from MRI, and this in this case is things related to white gray matters in the brain, and then we try to find if there is association with the cognitive test that the patient usually take in hospitals. This will validate the cognitive test itself, and also can give you a way that we can just take an MRI and straight away we can have better understanding of dementia. So similar project is actually done, but in this case, we did it for COVID-19. The only difference here, we're of course working with lungs, and we're trying to measure the oxygenation level, the hypoxia, in this case as a function, and then we extract again a structure from lungs and from, in this case, CT scan, and we try to find the association between them. Both of this work is always is in the second revision of their publication. So I'm giving also very quick view about some of the projects we're funding here. The first project is deals with, in the case, this is a core machine learning problem when you have unbalanced data, or we have data which has only one class. What do you do with it? And this is we're doing it in collaboration with University of Toronto. With Georgia Tech, we're working on a project on curricular analysis, and I'm glad again that Safran, you mentioned this. Thank you very much. It's personalized student curricula is very important to ensure that the student can graduate on time. So here we're doing also natural language processing to look at students, to look at courses and prerequisites, look at course outcomes and how we can provide each student with the right path to graduate. So number 3, we're working on in a project with Chinese Academy of Science. This is all to do with cervical cancer. We are trying to use MRI here and try to adopt segmentation methods in order to identify where the tumor is, and we're trying to get it accurately. Another project also with University Malaya in Malaysia that deals with the body language of patients. It's very important to understand the body language of the patient. It gives more input for the physician to have more informative diagnosis. Like a child in the picture here, there are a lot we can get from their facial expression and body language that could help in better diagnosis. And finally, the last project is just completed, which to deal with identifying protein complexes. I mean, protein functional complexes within human network of proteins. So here we use graph convolutional network to identify the functional complexes. We treated, of course, the network as a graph, and then we start to extract these subgraphs and make sense of them, what kind of functionality they lead off, and how accurate we can actually get them, because we can find a lot of proteins that could be within multiple complexes, and a quite challenging problem. This is already published, and we're trying now even to think of more improvement. I think I'll stop here. This is a flavor of the projects we're working on. Please, if you have any interest of any of this project, let me know, and then we can have other meeting. We can talk about the technical, details of the projects, and we can work together. Thank you very much.
Thank you very much, Dr. Nizar, for this insightful information. Really, I think the last one you should talk about protein complexes and build-up. It can be a mortal issue for many people, especially with old age. The protein built up on the heart make a stiff heart, and then the heart fail in the end of the day. But there's a lot of interesting issues we can discuss among you guys between Dr. Majdal and Dr. Nizar. The floor is open. I think I have 2 questions in the question and answer chat box. One from Dr. If I'm sorry if I mispronounce your name, Kushik. He says, dear Dr. Nizar, can you please explain how we can calculate the rewards in the reinforcement learning?
Well, briefly here, the idea of reinforcement learning is known. It's about trial and error. It's just think of a child would like to walk or learning walking steps. So if you go 1 step right, you get a reward. And that reward could be anything, sweet or whatever. If not, then you get a penalty. So this is a motivation for an agent to take the right steps. So this is the simple principle of reinforcement learning, of course, and reward from a system to system could differ. Depends on the requirements of the problem itself, but that's the general idea.
Thank you, Dr. Rizal. Thank you. Dr. Majdal have announced that no one will hire you for your knowledge, but they hire you for what you do with your knowledge. Now, the question will come with advancing in AI in the next years to come. What will be the difference between the human being intelligence and the robot machine or machine learning intelligence to do the same task, when the other side, the machine, have much more knowledge and information than human being? This is a question to open, but You have right, guys, to answer or to ask any other questions, please.
You know, I got an answer for this one, and thank you for asking this right question, and thanks for Professor Nazar for this fruitful presentation, and we may be in touch, inshallah, to discuss this research and see how we align and overlap the research we have and the research on their side. So regarding your question, Allah subhanahu wa ta'ala created human being with unique features that cannot be replicated by machines now and in the future. So creativity and sensing from a specific matters, it's something that hard for the machines to develop in the future. هذا خلق الله فأروني ماذا خلق. It's going to be machines in the future will automate some tasks. This is in the basic paradigm, but in the higher paradigm, it's going to be the computations power is very fast than human. They can calculate, they can process much more than what we can do in our minds. This is one advantage of machines, but on the other side, they cannot sense, they cannot, as a professor, let's say a report and a professor sitting in the class. You can see from a professor as a human being can sense right away, it's in less than seconds, what the students' reactions about his question. But for a machine, it needs a lot of data and a lot of cases to use this, and there will be an error. And if we go with the healthcare, as you say, healthcare surgeon robots nowadays are helping the doctors to do the surgery. We haven't seen any robot that's doing the surgery from A to Z, because they are just giving the surgeons instruments to help the surgeon to do the surgery. They're helping them to avoid the human being errors. This is one side, and to make the process very fast. But the human being involvement and intervention will be there for now and forever.
Thank you, Doctor. Thank you very much for the response. I have a question from Dr. Hiba. She's saying that have implemented any AI solutions for education in the UAE or maybe in Kingdom of Saudi Arabia? If so, give us some examples, please.
So I'll start AI in the UAE first.
Please.
All right. So I'll talk about the projects that I'm aware of, and we have completed them. One of them is the project I mentioned for detecting, of course, student at risk. This project has the first part, which is using rule base. We have already completed this. It will be published soon. The second, using machine learning, is also in the pipeline. But we are also now implementing another different way of looking at students and understand their performances. We're applying knowledge graph in this case, because most of the machine learning system, they treat each student is isolated of others. This is how machine learning works. Take roles and you don't really look at the relationship between roles. Of course, there are some association rules with the attributes, but always you treat what you call objects or instance in the data, independently. And that's why we're trying knowledge graph. We're trying to find relationship between the students. Then, and we actually did that, and we found there are a lot of things when we look at the topological relationship of the students in class. We try to infer more information, and we try to improve our detection accuracy. This is one. There is another project which related, the project I mentioned related to personalized curriculum has just started. It's funded by the Big Data Analytics Center. That's in collaboration with Georgia Institute of Technology. It's just started, but we also have a project which is completed when we tried to have an AI assistant in the class. And we experimented this in our lab, which is having a camera that could serve as another robot to help teaching. So we understand that there are a lot of things the AI solution or even a robot cannot replace teachers, but can assist in great way. For example, chatbot, also thankfully mentioned by Dr. Safran again, is can be used to answer all student questions at the same time. If you have 1,000 students asking questions, it could be straight away answered. The whole book could be provided in a narrative way or summarized quickly. By our cameras also, we detect students' behavior, we look at their facial expressions, we look at things like, for example, if the students are cheating or not, if you are speaking to your friend, and we analyze all that kind of data. And that kind of another help for the instructor, especially if you have a big class and you have a lot to monitor during the class. A lot you can miss. In this case, of course, robot could be very helpful, and by robot, not necessarily a weird robot in class, but a camera that could actually detect all that and give and provide an action. Also, we're trying even to go farther than this on looking at the textbook and how we make it intelligent in a way that to customize the materials based on the student's level of knowledge. We're working on this. It'll take a while because it has many dimensions to this project, but this is all circled back to personalized learning, and we're trying to achieve some of these steps. Thank you very much.
Thank you, Dr. Nizam. There's a question from Dr. Yaqub. He says that about the natural language processing, is there an application for this on newspaper sectors, especially in Arabic language? The floor is for both Dr. Majdal and Dr. Nizar. He's talking about the neutral NLP, basically. Is this artificial intelligence for that, for Arabic newspapers?
Majdal, or maybe can go ahead.
Okay, thank you. There are a couple of researches in this area for Arabic NLP, and it's not. I'm not going to say it's similar to the advance of English, but it's growing very fast, and we have seen a couple of open source implementations that are used in a couple of projects. There's, as Dr. Nizar said, in our university, we had a project that is developing a chatbot for students to answer their questions every semester, repeated questions. What is the time of this course? What are the courses I should register? Who is my advisor? So these are rule-based questions, can be studied and can be automated in such a way through chatbots. So there is an advance, to just conclude your question, there is an advanced research in Arabic NLP, and I have seen and noticed and worked with other groups in the United States on this topic.
Thank you, Dr. Majdal. There's another question, which is generic questions. This is, overall, we can notice that the skills gaps between the graduates and the future job markets requirements in the problem-solving analytics. What is the strategy used by both of your institutions to narrow the gap among future graduates? So we can see there's a gap today between what the outcome of education and what the job market needs, especially in AI.
Right. Can I start on this, Dr.?
Please, Dr. Nizar.
Okay. So, yes, we realized that. And I'm circling back again to Dr. Safran's remark on the future job market. It's not about knowledge, about how you utilize this knowledge, about skills, about innovation. So we are aware of that. And now to narrow the gap between the expectation of the industry and the job market and what we do, there are two things we always do. First of all, we bring in those entities to us to tell us their expectations. And often the answer is we need, of course, skills and innovations and somebody who is ready. And this is the reason why we started to look at the hands-on experience. We started to teach our graduates how they can be prepared and what's the expectation in terms of skills and innovations. For example, now, if even including in the Big Data Analytics Center, the hiring for research assistant, we hire from a pool of internship students who train in the center. So because the CV can tell you something, of course, the knowledge you cannot, and the skills you cannot determine it from the CV, but those individuals, when they have training in the center, work on real world problems, and you can shape them to the needs of what you want, then you can end up having really good candidates. And by the way, most of the industry and government, they started to do this. They started to provide training to bridge this gap from their side, but from our side, we are aware of this, and we try to polish more hands-on experience and skills because we know it's needed. Now, if you are in machine learning, we always advise the students going and contributing to GitHub, get solutions, make it out there. Everyone will recognize you by the solution you posted, by the level of skills you have, by projects that you can show. And we are lucky that we have this kind of platform like GitHub and so forth. So if you are a graduate or about to graduate, please do this. Try to polish your skills, try to post all the knowledge and projects completed in GitHub. You never know, sometimes you can be called for a job just like that. I call few people and I hire them by project developed in GitHub. Thank you very much.
Thank you, Dr. Nizar. Dr. Majder, would you like to complement that answer? Okay.
Yeah, I think Dr. Nizar covered the most of the point that I would like to mention. So I see more questions. So let's move on.
Yes. Thank you. There's a question from Haytham. Says, what's the major difference between ML and DL, the number of neuron layers?
All right. So the answer to this is machine learning is, as I mentioned in my talk, machine learning is, of course, finding patterns, right, using algorithm and data, as mentioned. But deep learning is automating this process. So in both cases, if you think of it, number of neurons or number of layers or the neural network architecture, it doesn't matter. It doesn't define this is a deep learning really or machine learning. We know that in deep learning we consider more layers, right? And to give more ways of improving accuracy in the prediction. But overall, it's not about you cannot use neuron to define this or define that. So in both cases, you can use neural network, whether I'm just having small data and I'm using neural network. Somebody's using deep learning could use also neural network, because in deep learning, the step of feature extraction is the automated part. After that, what you happen, let's say you have image. You take this image, you make it into grid, right? You use filters, then you stretch your all what you call variables, and then become a suitable input for fully connected neural network. So the neural network become now irregular machine learning work that could actually learn from the input.
Thank you, Dr. Nizar. I think this question goes to Dr. Majdal. How AI projects and research will endure or introduce various ethical implications, especially in healthcare settings? So we're talking about the ethical issues and the healthcare and AI.
Yeah, yes, this is, I was reading this question while Dr. Nizar was answering, and there's another question down there is related to this. We'll answer both of them at the same time. It's privacy and secure privacy and ethical implications in healthcare. So data privacy is a big issue. And it's, as we open the gap, as we open the cap for the data privacy, we get more services, we get more technologies, you get more benefit of AI. The more you restricted the data privacy, the less you get as benefit of AI. But it's a research by itself. Ethical implications in healthcare, AI healthcare, is a research by itself to improve the data privacy in AI systems where it's installed in healthcare, even in education, not only in healthcare, it's also in education. How are you going to use this data for those students? Is it allowed to use their data, just recording them in class, using this data? Is it approved, is not approved? For schools, for high school and elementary schools, who's going to be involved, parents, and etc. So it's a lot of issues here, and the research is going. As we move forward, there will be data privacy issues and needs to be addressed, and the research is going on in this track. Is tracking data privacy issues.
Thank you, Dr. Majid. This question again goes to you. I think I've read it before. For nursing patients remotely at home, is it limited to certain patient conditions, or it is open for all kinds of patients?
No, I think it's open. As I see it, it's open and helps. It's kind of a chatbot, but it's especially for visualized virtual nurses. So it's kind of how you personalized my visit to this doctor, to this hospital. In the past, you go to the doctor, next appointment in 3 weeks, nobody interact with you until the next visit. Now what they want is from the first visit until the next visit, we need to know about your health conditions so we can improve the actions that will be taken in the next visit. So it's open. It's not related to specific diseases or specific patients.
Thank you, Dr. Majid. Our last question is here. Is it possible to integrate AI into academic education and basic science? For instance, in anatomy, science, certainly in teaching students in discussions hall.
All right, let me take this. This is a tough one. So, because it depends. It depends on the subject, but there are generic way to use AI in whatever course is. Of course, you can use it in the way you deliver your course. This is regardless of the material of the course. As I mentioned, in personalized education, could be used to personalize materials, teaching materials. Could be used to personalize, of course, curricula. Student could use some tools or the instructor to know what am I supposed, or what's the expectation out of this class, whether I'm gonna pass it or not. That's all can be done, of course, and we mentioned methods to do this. So, but also we can use things like we mentioned it before, like the chatbot. The chatbot could be customized in a way that answers students' questions with respect to certain subjects. Of course, you need domain expert here to come up with the right questions and right answers. You can have pool of questions and then leave it for this for the AI chatbot, because it learns from multiple questions and it can come up with different solution, even if the question is not exactly asked in the same way, if it's not frequent. Now it has the capabilities to just pick one word and try to find answers to that. So students can have answers related to anatomy, for example, or any basic science. Another thing which I think could be very interesting is it depends on the topic. For example, I teach sometimes bioinformatics, and I found using AI and machine learning, of course, in biology is fascinating. And there are solutions in there where we can actually take the data and show the students how AI and machine learning helps. The projects of, for example, I mentioned here, which is the protein complexes treating the whole network, the whole biological network is just like a graph. It's another application of AI in that subject. So this could be a different way of engaging this, but of course, here you need to be familiar with the field before you can actually show these solutions. For something generic, it takes a while until, let's say physics, it takes a while until AI specialist and the domain expert to sit together and find applications or find a way that it can be illustrated or described or even problem solved using AI and machine learning. Thank you very much.
Thank you very much, Dr. Nizar, for this information. Please,
if you don't mind, Dr. Sultan, I have one comment on this question because it's a very interesting question. So my vision on this is AI will be taught in all the fields of science in the future, because it's going to be integrated with everything we see in our lives. Let me give you an example that we are doing right now at King Saud University. We're doing a research and a project with the marketing department. So we are helping retail stores to study their customers' behaviors inside the stores, to know how many people are coming in, how many people are leaving, to conversion rate and the dwell time of the people inside their stores. So they raised the issue from a marketing point of view. So AI is jumped now in the marketing. So their students should know how to increase the marketing for these companies getting the benefit from AI. So this is just an example that we are doing right now, and it's going to be expanded for all the academic educations, including anatomy, science, and all other science. So I'm sorry, Sultan, I jumped in to add this because we are facing this and we have experienced this in the past.
No, Doctor, you're quite right. That's a very important subject. We are against time. That's why we have to rush and understand the implications of AI. And it's good to understand the gap between education and the job market, which is accelerating and going to directions never seen before. I think this is very important. There was a question that if we could have a specific webinar later on between Dr. Nizar and Dr. Mejdal about the protein build-up, complexity, and AI. I think we have to think about it, inshallah, in the near future. Unless there's any other questions or a last-minute talk somebody would ask. I don't know if there's anything else we can host, but otherwise, I'm really grateful for your time, for your thoughts, and for your wisdom. I think we are in the right direction with people like yourself guiding us into the future. And again, thank you, Dr. Mejdal from King Saud University in the Kingdom of Saudi Arabia. Thank you, Nizar, from the United Arab Emirates University from Al Ain. And I'm sure we'll see you, inshallah, again next time in some other sides of webinars. Thank you much. Have a blessed weekend.
Thank you, Dr. Sultan.
Bye-bye.
Thank you, everyone. Thank you.
Recording stopped.